Hi, I'm Peter Hogarty, one of the engineers on the team who designed the Midnight Solar Little SOB rapid shutdown system. We're standing inside our test facility outside of wonderful Building 4, and what we have up on the roof is 12,000 watts of Kyocera PV arranged in 3 strings of 12 modules each, and further down we have a Dow powerhouse installation providing about another 1,800 watts. And here's how we have it arranged inside. In the ceiling, we have access to every module in each string, and that is fed into a breaker panel where I'm able to switch each string individually or put them in series. That way we can adjust the voltage and string at will. From the breaker panel, the PV comes out in access boxes here, so I can use the PV for each of our test inverters. Now I'm going to show you the Little SOB system units. The Little SOB system consists of 5 units. Oh, by the way, that's not a joke. The SOB stands for Shutoff Box. Midnight Solar has a product that is called the SOB, the Shutoff Box. This is the Little SOB. There is the AC transmitter, connects directly to line. There's the DC transmitter for areas where line voltage is not easily accessible. There is a 600 volt receiver meant for 600 volt strings. And there is a 1000 volt receiver that is meant for 1000 volt strings. Additionally, this unit is low profile and has been designed especially for high temperature and high reliability ratings. All units are certified by TUV, and further details for each unit and the TUV certification can be found on our website. Now here's a typical installation in a SIMO or Primo backplane using the AC transmitter. Here we've got the AC transmitter, and it's mounted on the rail in back. We have AC connections to line 1 and line 2, and it doesn't matter whether it's line 1 or line 2 or line 3 as in the SIMO. It doesn't matter, just as long as we have AC. And running down along here is the coupling coil. Just a big toroid that couples the signal that comes from the transmitter, runs through our PV up to the receiver. We have a 1000 volt receiver here. We're going to be running 2 strings in series for the SIMO, and it is powered by the last panel in this string. That's where the receiver gets its power from the panel that it is controlling. The way it works is we have a signal that is comprised of 2 parts. One is a bit encoded signal, and that signal is carried by a tone of 485 kilohertz. So the receiver not only has to receive 485 kilohertz, there's a rather narrow filter in here, but it also has to receive the correct bit pattern. That's your keep alive signal. No signal from the transmitter, the receiver shuts down. The transmitter turns on, transmits a signal, the receiver turns on. After turning off, there is a 5-second delay before the receiver shuts down. That is another level of security in that a glitch or some false triggering will not affect the function of the receiver. Now here we are, we've got the 1000 volt unit hooked up to 2 strings in series, and we're going to run the SIMO on this. So all you do to activate the rapid shutdown is just turn on the line disconnect. And we're powering up. We've got a voltage of 829 volts going into the inverter, and you will see that we have 2 lights in here. One is yellow that blinks upon reception of the keep alive signal, and the other is red, which indicates that the unit is now active and allowing DC to go through the string. And here you can see we're at just a bit less than 3,800 watts, which actually is pretty good for April in Western Washington. Now I'll show you what happens when we shut down. You can see that we're running at 670 volts. That's under load, 3,800 watts. And all we need to do to shut down the little SOB, flip the AC disconnect. 5 seconds later, it turns off. And we're shut down. And right away, you can see that we're down to 15 volts, and that is the bleed down within the SIMO. Okay, that is the AC transmitter, 1000 volt receiver. Now I'd like to show you the DC transmitter and 600 volt receiver, and we'll do that a little differently. So here we go. Now you may be wondering why we even have a DC transmitter, seeing that all inverters, all grid tie inverters, are hooked to AC. Well, hey, let me show you. What if you have an inverter where AC is difficult to access or completely unavailable? For example, the SMA Sunny Boy. We've got PV in here. AC grid is right here, completely inaccessible for a transmitter. On the Reefview, we've got DC input here, AC grid tie here into 2 completely separate boxes. Well, all you do is just put the DC transmitter here, hook it up to a 12 volt power supply, 12 to 16 volts. If you have access to an internal auxiliary supply, that would be fine. A wall wart, bench power supply, doesn't matter. And just loop it around the PV plus input. All right, here we've got the DC transmitter. We have a 600 volt receiver hooked up to 1 string. That'll be the single string. I'm operating a Primo 3.8. There's 2 reasons. One, to demonstrate the DC transmitter, and the second, I will be demonstrating the bleed down box. Since this doesn't have bleed down internally, you'll need to use a bleed down box with it. And of course, this has a DC transmitter in it. So, here we go. I'm using just a bench supply. Grid. And we're up and running. Now, here's a feature that I didn't show you earlier. See the red blinking light on the transmitter? That means that the keep alive signal is being transmitted. There is light in the DC transmitter and in the AC transmitters. Now here we are up and running. We're running about 1800 watts, which is what I expected on a single string. But that reminds me of something I forgot to tell you. The capabilities of the little SOB system. So far, I've just run a single receiver on the end of 1 string, be it 12 modules or 24. Well, what can this do? We've run up to 5 string level shutdowns, 5 receivers on 5 different strings. So we can do that. We've done that in another test facility. We can't do that here. We've only got 3 strings available to us. we can run module level shutdown, and we have. We've run up to 36 receivers, one on every individual module in each of our 3 strings. So where it ends, who knows? But here we are at 1800 watts, and I'm going to shut down now. Count down, 5 seconds. Boom, right there, and we're shut down. Okay, well, that doesn't take care of the bleed down problem because the Primo 3.8 doesn't have it. So now we're going to look at the Midnight bleed down box, which is right here. Oh, I forgot to mention, there is one thing. When I shut off the little SOB, all I did was turn off the DC power. It is not disconnected from the grid. Grid disconnect has to be done separately. This is the Midnight Solar bleed down box, the little SOB bleed down box. And it's a little different. It comes in a gray plastic box. It's an NEMA enclosure. You'll see it's a little messy because there is no standard configuration for wire feed-throughs and mounting. Like, you know, it's up to an individual installer to install fittings as they see fit. But what we have is AC and ground, and this is for convenience and for the initiation of the bleed down sequence is connected to the AC grid tie disconnect. We have PV plus that runs from the string, PV plus that runs from the bleed down box to the inverter, and it has the transmitter toroid on it. We have PV minus coming in, PV minus going out to the inverter. The way this works is we sense the AC power that is applied to the unit. And there is an AC to DC converter. This is your standard DC transmitter. We're up and running. We'll wait a couple minutes here to get some power on, and I'll show you the actual function of PV plus and PV minus voltage bleed down to ground. Okay, we're up and running. We've got about 1900 watts, and our array voltage is 347 volts. And take a look over here now. And we see the meters read a bit uneven, but that's quite normal. We've seen in proper operation. Now, since the bleed down box is AC controlled, I'm going to shut off the AC disconnect. That does 2 things. Number 1, it turns off the transmitter, which disconnects the receiver from the string, killing PV voltage. And secondly, it initiates the bleed down process. Take a look at the meters. Here we go. Shut down. Count it down. Right there. And just several seconds later, much less than the 30-second requirement, we are at 0 volts from PV plus to ground and PV minus to ground. That is how the bleed down box works. That's about it. You've seen the operation of the AC transmitter and the 1000-volt receiver. You've seen the operation of the DC transmitter and the 600-volt receiver. And you've seen the operation of the bleed down box. That's about it. I want to thank you very much for joining us here at Midnight Solar. If you have any questions, comments, suggestions, if you need to find out more, please don't hesitate for a moment to get a hold of anybody here at Midnight Solar. Robin, myself, my email is peter@midnightsolar.com. And that's it. I'm Peter Hogarty saying thank you very much. Enjoy.